So let's check, guys. Yeah, so it's very clear, I think so. Now let us try to have just a minute. So previously we discussed about motion in two line and how the particle moves and about its velocity, displacement, acceleration, and all those parameters we have discussed. Now in the and after that we have discussed about the projectile motion, which is the best example of 2D motion, right? Now we'll continue that projectile motion about yeah, okay, we'll continue about the projectile motion in advanced level. First of all, let's prove that the path of trajectory is parabola. For example, if you throw an object, then what happens? Obviously it looks like let me have wait. Yeah, obviously it looks like, for example, when you have thrown an object, it looks like in this reverse parabola, right? So now here for this shape there is an equation in the mathematics. For example, if you get straight line, then the equation for this straight line is equal to y is equals to mx plus c. Okay, at the same time y is equal to mx plus c for the straight line. For example, if you draw the graph for y is equals to x square, then you will get a curve path like this, right? If you draw for y is equal to mx plus c, in the sense nothing but a straight line only, right? And it is y is equal to x square. For example, if you draw a graph for the y is equals to root x, then you'll get a graph like this. So for every shape you have one equation in mathematics, right? Likewise in for projectile motion there is an equation, right? It looks like reverse parabola. So let's prove that the trajectory of the projectile is a reverse parabola. Okay, so for this what we'll do is we'll have let us say have a projectile. Yeah, let's have a projectile. This is right. Yeah, okay. Now just imagine we have projectile, we have projected, this is x-axis and this is y-axis. Clear? Now we are projecting an object. When you have projected, it follow this path, right? Yeah, this is the projectile path. Now this is the path of the projectile, right? So now initially I projected this with the u velocity. See, this is initial velocity. Okay, so I have projected this an object with the u velocity, and you know that it is making an angle theta with the horizontal, and this u can split into two components. One is u cos theta and another one is u sin theta. These two are the two components of initial velocity. Means along with x-axis the speed of the projectile is u cos theta. I mean, I can call it as a right ux, and this is uy. Along the y-axis the initial speed is u sin theta. Here along with we know very well in the previous class we have discussed that along with x-axis there is no acceleration. Along with x-axis is 0, but along with y-axis acceleration is minus g, right? Minus g is the acceleration along with the y-axis. So now here uh, half, because of this there is no acceleration, the velocity along with horizontal is always constant, right? So now here the range means, like, let us take distance. X is equals to, means x in the sense distance traveled along the x-axis is equals to horizontal speed into time taken, right? So now from this what you'll do is I can write time is equals to x by, what is ux, x by ux, that is equals to x by u cos theta, right? U cos theta is the time along with the, I mean, x-axis, right? X is the distance along with x-axis, right? Horizontal distance is equals to horizontal speed into time. Clear? So now here for the vertical, along with vertical, let us take s is equals to ut plus half at square, right? Let us apply along with y-axis uyt plus half ay t square. Okay, so now here if you observe carefully, sy is nothing but u sine theta, that is equals to, sorry, what is sy? Sy is nothing but y, because displacement along with y-axis is y. Okay, that y is equals to uy in the sense u sine theta t plus half into minus g t square, right? So this equation gives the y value, right? Now for example, after some time the particle is here, so what is the value of this particle on y-axis? This y value you will get by using this equation, right? To solve many problems also you can use this relation. And next what we do is we'll try to substitute t value. We'll try to substitute the t value in this. So y is equals to u sine theta into, what is t? X by u cos theta, right? X by u cos theta minus half g t square, t square in the sense x square by u square cos square theta, right? This is the t value. Let me have, okay, this is the t value. Now from this y is equals to, here you get cancelled,